Okay. Hello, everyone. Welcome back to another session of All Things Go. And like your usual planning, we are going to decide on some meeting agendas. And before the meeting starts, me and on the meeting, we were talking about how we can start a project that we need in Andamio, and we want to answer some questions. And there are some solutions regard to that question, but we wanted to actually go through that journey here. So what we were thinking was Andami indexer. By indexer we mean that we need a set of data that our project needs. We need to retrieve them from blockchain, somehow storing them, and then provide those information in a very structured manner, and send that to the places that need these information, whether it would be other projects or front or back end, anywhere. So we want to go through that, but if anyone has any questions from previous sessions, or if they are facing some issues or any question in regards to what they are doing or what they are about to do, feel free to share it, or open your mic or share it in the chat. And if not, we can start with this agenda. And also, I had another thing that I wanted to share, but I think we don't have time. I'm facing some issue. I already shared that with Chris regards to Seaboard, some stuff that I'm facing. I just wanted to show my code that maybe I'm doing wrong somewhere, somehow. But anyway, we will talk about that later. But yeah, that would be the agenda. I'm suggesting to start a project from ground up. And within that project, we're going to cover a lot of things, from the basic of the whole Cardano blockchains and others, till to really full-fledged application, something that a project can rely on it. We can do, uh, things like we are not sure, but even making Andamio indexer, or the thing that is going to come out of this project, something that other project can pick that up and use them for themselves. Even Gimbalab indexer, I don't know, any indexer. I'm sure we need to touch many concepts. I personally need to refresh my memory about many things. Last time, me and James picked up this indexer around a year ago. Things were different, tools were different, the availability were different, and the needs were different. So we decided to not start from that. We decided to start from scratch, something completely genuine, new, and going through an actual step of building a project, starting asking a question, and then trying to answer that. And probably, maybe even this session, by answering all those questions, we found that, yeah, a NAM indexer cannot be built in Golang, or at least the part that we need or we think that is going to be built in Golang doesn't make sense. So yeah, that's one possibility. But even that would be, I think, a good journey. It would be an actual journey for anyone that who has some business idea or business logic, and then we can look in other solution. So yeah, that was the idea for Andame Indexer. I've already Built or created a an empty place, a blank project, and just making ready for starting the things. But sure, before starting the code, we need to know, what what they are going to do. So again, if anyone doesn't have any questions or agenda they want to talk about, um, I suggest to start on Damio Indexer. Let me bring back. Yeah, that's something. If we have time, we will talk about it. Anyway, so I guess I guess that's kind of show that we can start the Andami Indexer. So Nelson already thought about this Andami Indexer and even wrote a really simple pseudocode like what do we need, what sort of information we need. He also has done some R&D about available solution. For example, we have something called Yahtzee. Yahtzee in GitHub. Hopefully you'll find it. No. Where is it? Let's see. Look. Cardano, GitHub. Yep. So there is this Cardano mini protocol implementation in Java, but there is also this Yahtzee store, which is a Cardano data store implementation using Yahtzee. And the data store basically means, again, indexer. So it retrieve the information, store it somehow in a database, and provide a bunch of endpoints to, just for people to use it. But the thing is, I'm not a Java developer. And after the research that we've done and also talking with Cardano Foundation, you need to not have really good or great knowledge of Java, but yeah, you need to be familiar with Java and Java environments, JDK, and installing all sorts of things with Java. I don't know if you experience with Java or not, but the whole JDK is sometimes become pain in ass. Oracle is not really Oracle, the company behind Java, is not really uh, doing great work in supporting these. So yeah, the environment and the packages are also sure you need to familiarity with this. So we thought that we have something great here. Blink Lab already provided something really, really great. Other we in last year we used kind of version of these other. I mean, the name was different, but we used that. It worked great. But again, that was for different needs. Now we have different needs, which we are going to talk about. So yeah, we were wondering that can we use, Adder, and if we want to use Adder, should we use other tools as well? Yahtzee and Yahtzee Store apparently is really mature in their own way. But again, to be honest, uh, for a reason that I said, we don't have a Java developer. We don't want to go to another path. Although it can provide a binary, we can just kind of use that binary. But yeah, we just want to know that is it possible to kind of implement what we want, but not using Yahtzee or Yahtzee or anything Java. Not so. If I coming back here, let me a bunch of things here. So Nelson already provided some insight. So let me ask him, Nelson, would you please share again those questions that you asked, the things that we wanted Andami indexer provide for us?
Yeah.
If it is
So
possible, please. I mean, if you have, it is. Let me share this
yeah,
page to you.
yeah, I got it. I got it.
'Cause,
So yeah, we for easy access we want to uh, store UTXOs uh, at a given address, right? I think it's easy, maybe easy. And then store the transaction history uh, of transactions that interacted uh, with a given address. Um, and the third one is that uh, these addresses that we are looking into, UTXOs and transaction history, like when we are running the server, we want to dynamically update the list of address being watched. Yeah, dynamically uh, change or add more addresses to the addresses.
so the new addresses will come from blockchain. This
Yes,
dynamically changing, adding the information comes from blockchain, right?
yeah,
Okay.
derived from reference, reference grid stored in the UTXO. Yeah.
Thank you. So, okay, so these are the needs that we have for Andami Indexer. And, well, the simple question is, can do we have the utilities to uh, do these? Uh, I, and also, I should say that, well, because of the UTXO RPC, we have the plan to use UTXO RPC. So, sure, it is possible to, maybe that would be the way, but maybe the UTXO RPC is not the way for, that getting the information and then chop down into the one that we just mentioned here, Nelson mentioned here. But yeah, the normal way is just asking a blockchain explorer, for example, Maestro or Blockfrost. But due to your experience with Maestro, especially, some of our transactions, some of the query that we need always hit the query limits. Like we cannot ask like 20 or 30 queries at 1 second. The reason is just because of several users are using exactly the same transaction, just hit the limit. Although I'm saying it is a paid account, it's not even the free account, still we're hitting the limitation. So we were thinking of retrieving this information from a local node, a node that we're on, like Dingo. So that was the idea, and we want to explore. So Dingo provides the information, an adder. By using adder. Um, we and I think we have UTX RPC here. So yeah, uh, just let me ask Chris. Chris, do you think, just in really high level, uh, by using adder and Dingo for retrieving the information locally, can we answer. Can we do these three things? Like, do we have the enough utilities or tools or code? I don't know. Are they mature enough to do this?
I mean, you're gonna need somewhere to store it. Like we definitely don't store the transaction
Yeah.
history like that. I mean, you can actually get it, but we only store like the blocks in the UTXOs and then the specific states. So like we're not actually storing the individual transaction. Does that make sense? In other
Mhm.
words, transactions are either a property of a block or a property of the UTXO, right? Um,
So if we retrieve the block, can we retrieve the transaction from that block or no? That block that we
yeah, of course. But what I'm saying is you're gonna have to assemble your own history.
yeah.
Yeah.
Yeah, that was one of the also the question that if we want to store that, because Yahtzee store it, they already have a data structure, database solution, everything. But we were wondering that is it worth to come up with a data structure? I don't know, going through some database solutions and storing that or not. Like we were thinking about ORMs, like Gene, the famous one, or just going like not using ORMs. And the suggestion from other people was PostgreSQL, but I don't think we are going to go with the memory database like Badger. We have to store that somehow somewhere. And I think the solution
Okay,
should
well,
be
Badger's not a memory database.
so yeah. I missed that.
Badger's a key value store.
Key value. Yeah, sorry,
Yeah.
forgot about that. Um,
Anyway, so Dingo uses SQLite and Badger DB. We use Badger for the raw object store and SQLite for all of the metadata. And we use Gorm for an ORM underneath of it.
mm, oh. Uh, just based on your experience, should we care about the performance? Because like right at this stage, like, hey,
The performance you care about is not your indexer. The performance you care about is the database that you're writing it to. All of your reads are going to happen on the database, right?
yeah,
So,
reads and write, yeah,
you are in the classic example of you're attempting to optimize for something you haven't even written yet.
yeah, exactly.
You do not start with optimizing first. So yes, an ORM is the simplest and easiest way to write this to handle things like your database migrations and your connections and retries and all of that sort of stuff that is already built into Gorm. Otherwise, I mean, you can write raw SQL for everything, but it really is not going to gain you much because we're not talking about ridiculously complex SQL here. We're talking about
No,
storing UTXOs by address,
transaction,
essentially.
yeah,
I mean, that's literally all that you need is UTXOs and transactions by address.
yeah. I mean,
So,
at the beginning, sure, it might become more uh, sophisticated, but yeah, that's the thing that we need right now. It's just
right,
these.
right.
Okay, so QRM, we can go for the using this QRM, and for a SQLite, we had. James also has experience with the SQLite regards to the first version of Andamic Excel, which is pretty good. It's great. It was great. We can go for that, but I wonder, like, does it matter, these databases? SQLite is relational, Badger is not. It's key value. For such things, because we were wondering about the data structure, if you want to store that somehow.
You can just store the entire CBOR as a blob in SQLite. That's perfectly fine.
CBOR as blob. What is blob, Chris? Sorry, I was like just like
Blob is a type. It's a binary type.
blob. Okay, let's write down some notes. Notes. Using GoRM for database handling. Let me also put this link here. Where is it? Here. Okay, and then storing the whole CBOR as blob. I mean, a suggestion. The suggestion is storing the whole blob. That can explore that. And the other doesn't. Other doesn't store UTXOs or TX.
Adder doesn't store anything. Correct.
That doesn't. So TX or anything, in fact. And the other in here.
Hi, Chris. So yeah, the question I had with like watching the blockchain, like, is I am looking at the what's TX specification for UTX or RPC, and like, are there any difference in running an adder and watching the blockchain and simply watching TX from the UTX or RPC? Yeah,
No, not really.
so it's the same.
Yeah, I mean, it's essentially the same.
So Scott is asking about what is Gora and what is Badger and what is sorry, Scott. What is Dingo? I don't know. So GoRM here is a library for managing a database in Golang. So if you are familiar with any database, you need to talk with any database. We have different sort of databases: relational, non-relational, NoSQL, key value, etc. And you need to query, you need to talk with them to read the data exactly like here. Where is it? Yeah, reading, updating, deleting, writing, finding. These you need to talk in a programmatically way. So GoArrow is going to make your life easier because each database is going to have their own unique queries or unique ways. Sometimes they try to optimize things, therefore they shorten their queries, their commands. So you have to know all of that. And if you miss a comma, or I don't know, if you put some extra space or something in that query, it might really bother you, and you have just, it's going to have a really hard time. So building that query is going to be really kind of hard, and you need to be careful about that. But GoRM, no, it's to help you with queries. Sure, still are ways for mistakenly doing something, well, but still, it helps you, as you just see it here. It just helps you to do many things, uh, and that's the whole thing. GoRM is or GORM or ORM. I mean, we have other libraries that.
Yeah, so GORM is a Go object relational mapping. It's explicitly for mapping Go types to SQL types and for performing queries on that stuff. So there's a whole bunch of detail about that, but that's really what it's about. It's about mapping your Go types into essentially a SQL type that and how to interface with those. Um, so, real quick, I wanted to shortcut a lot of this because we're digging deep into like GORM, which I'm not sure is necessary for our requirements because GORM is not part of our requirements. So I'm going to try and help shortcut a lot of stuff. You can probably directly use Dingo's database as part of your requirements. So if you go back to Dingo and you look at the database package, all of our packages are designed to be used independently. This database package actually has nothing outside of this package that's necessary. So you can go and you can create a new database. Use it. Yeah, go ahead and look at database.go. You can create a new database, and creating that new database will create it with both a blob store and a metadata store of both SQLite and Badger. But you don't actually have to use all of it. You get what I'm saying? So the main thing is creating a database creates the data stores, and then if you go back up to database real quick here on the screen and click on UTXO or T yeah, like click on UTXO, right? And here you can see where we're tracking all of the UTXOs by their transactions, right? So we do have the transaction IDs of when they were created in the UTXOs. So you would assemble a transaction by looking for all the UTXOs, right, or whatever from that transaction. Anyway, the point is if you look at this, we already have all of the functions for setters, getters, all this sort of stuff. So scroll down and look at what we have, right? Like we have a new UTXO for creating a new one, looking up UTXOs by ref. So if you know which UTXO you're looking for, we have keep going, keep scrolling. I'm past this. Yeah, UTXO by ref, right? We already have it. So the point is like we already have all the SQL queries, all the ORM, all the GORM, all of that junk is already done. All the Badger is already done. This load CBOR that loads the actual binary data out of Badger. Scroll down a little bit more. Keep going. UTXO by address. So this will give you all the UTXOs by an address. And right, so we actually wrote helpers in the metadata plugin for doing all for like looking up all this stuff. But my point is if you're using these things, we have the ability to save UTXOs, we have the ability to retrieve UTXOs, we have the ability to delete them, we have them, from this stuff. So you don't need all of Dingo because the rest of Dingo is all the stuff like all the syncing and all of that sort of stuff. But you could directly use this database interface and publish the data into it. Because if you look, like some of these are explicit, like unspend and spend, like that sort of stuff, is going to be for as your, uh, uh, sorry, rolling back and doing rollbacks and that sort of stuff.
Yeah.
So I mean, we already have, like all of the things for removing, deleting, creating, storing, all of the UTXOs here is basically what I'm getting at. So you could use this database package. You could use just the UTXO part out of it, right? And then you could actually feed them, feed the UTXOs into the database using these functions, but you could feed them in however you want. So you could create an adder, that's pulling them in and then setting them, right? So like if you scroll up a little bit more, you can see where we actually save UTXOs.
New
So
UTXO.
new UTXO, right? So new UTXOs where we're actually saving the UTXO into the database, right? So but you can see below that the metadata, the demetadata set UTXO, right? So if you generate a new database, so now go up to database here for a second. Go back up to the top. Yeah, database, and then go to plugin. No. Go back. I'm trying. Yeah, plugin, and then yeah, metadata, and then store. And so if you look at this, this is the interface that's available in the metadata store. So these are the actual queries that you can do directly to the metadata store. And you'll see that they use all of the Goroboros types, right? So if you want to get pool registrations, you do it by using a Goroboros L common pool key hash. That'll give you the registrations of that pool, right? UTXOs, P params, get UTXO, right? Is by transaction ID. That one's easy. That one's always going to be transaction ID because you don't know what it is ahead of time. But my point is, you see that the way that we built it is using the primitives, right, from Goroboros. So, things that you get out of Adder, you can directly use in the database because I tried to make it so that the stuff that you're passing is the underlying like ledger shapes, the Goroboros shapes, that sort of stuff everywhere, because we want this stuff to be reusable, right? So our state directory is like our actual and chain directories. These are things that are like more specific to a node. But the database directory is specifically about how you store that data, and it's all certificates, UTXOs, blocks, right? Like all the generic primitives that we need. If you go back up to metadata at the top here, yeah, metadata and SQLite, and then models. So in this directory, you can see we have these are all of our like database models for all the things, and I'm trying to fill it all out. We don't actually have a transaction model because, like I said, we don't actually track transactions because we're tracking UTXOs, and we can get the transactions from the UTXO table. But I mean, you can see like the way that we essentially track them, and yeah, the CBOR is not actually in this table because we store it in Badger. But again, all that's handled transparently already for you if you were to use this. Now I'm going to have you go way back up to the top again to Dingo database. And I want you to go look at database underscore test. And so database test here is isolated, right? So it's not using anything else. So you can see where we create a new database uh, uh, down here and use it. Yeah, so we create a new in-memory database by providing it, yeah, this database new, by providing it with no data dir. If you provide it with a data dir, it'll be persistent. And then you can actually just use all of the things. So here you can see we didn't even use the data. We created our own table and directly created a test table and fed it with test data. So the point is you don't even have to necessarily use all of the things that we have in the database. You can create new tables that if you want, right? Like whatever, but it'll automatically create all of the tables that are shaped like those models that I just had. So it already has epochs, UTXOs, etc. already in there. So I'm just saying it might be a shortcut to try to use that, and you can directly use this database package completely outside of Dingo. It's completely standalone.
Yeah, thank you. But a silly question. Using this database package, should we like? I mean, maybe I'm forgetting something. Again, this is a good question. Copying all the database code base here, Dingo, and bring that into the dummy indexer here as a package, or I just can import that.
Import it. Yeah,
Import it. It is possible. Okay, so okay.
Yeah. It's literally a public package. You should be able to import it directly. That's all we do inside of Dingo is import it. So you should be able to do the same thing. Like I said, if you look at the database test, The database test is it is not part of the Dingo or the database package. It is package database test. It's a completely separate package. So it is a full example of using the Dingo database package isolated. See what I'm saying? This test is using it completely isolated. Now they're putting different data in there, right? Like so this test table is junk data, but
Yeah.
you could use it to populate UTXO instead.
Yeah.
Right. So
So thank you. So actually, that can be the answer. And absolutely.
I'm just saying, like, it might shortcut a lot of making those decisions, right? Like, of what's your database shape look like? What's all this stuff like? You don't have to. You can
Well,
just
thank you. Actually, we had all these questions that what should be the model, the data structure, how should we store it, relational is better, or key value, or I don't know, SQL better. That's answer all of it. Using database package in Dingo for database and data handling in the indexer. Thank you. So now the other question, actually, if does anyone have any question? No. Okay. And
So
go ahead, go ahead, Nelson. By the way, Nelson,
Chris,
would you please
in
little bit your audio is probably loud for some other. Is it if it is possible, please increase your audio. If not, continue.
yeah, think I think I cannot go more than this.
No
Um,
problem. No problem.
any problem hearing my voice?
No, it's great. Just it's like in the volume's loud. That's it. But no problem. Go ahead.
So Chris, when Dingo syncs, does the chain sync, chain extended stuff, uh, it it directly stores the block data in the database. Is that it? And you're saying that the block data itself contains the transactions, and we have to reconstruct the transaction history by reading, uh, by looking into the blocks and figuring out all the transactions.
yeah, that wasn't at all what I said, but okay. Uh, no. So Dingo has a bunch of different things that it does, but what we don't do is store stuff by transaction because we don't actually care about transactions explicitly. However, we do have UTXOs, and we have when a UTXO was spent, which means when it was used as an input, and we have when the UTXO was created, so we know the outputs of the transactions. So we essentially have the possibility of it. If you want to get a transaction explicitly, the easiest way to get that to start with would be by processing the blocks. So, in what I was suggesting would be you're essentially using something like adder as a library, right, as your starting point to fetch the blocks and to, get those transactions and blocks and things out of it, and then saving the things that you want using Dingo's database store so that you don't have to rewrite all the database stuff. So it's the same design that you have here, but so you're going to do most of the processing still in adder. The main thing is just now you have a data store. We don't have a way to search by transaction, but that could be something we could easily add. And again, after you've plugged into our database, you actually can just use any Gorm query too. You don't have to, like, any data SQL query. You don't have to use the ones that we've already built. We've just already built quite a few. You can add a new one. So if you wanted to, like, get all your, like, generate something that looks like a transaction, get all transactions by or get all UTXOs in a transaction or something like that, you can create a query easy enough to do that, and just that one query would be the only thing you'd have to create yourself.
Right. Um, so Ether works fine. But if I have a sync Dingo, like completely sync Dingo node, then I already have the data in the .dingo, like the database that's created when I run Dingo, right? And I can, like if I have it locally, then I can easily fetch it from there and reconstruct whatever structure I want, right?
You could, yes.
Right.
As long as Dingo wasn't running, because it uses SQLite, so it has an exclusive lock. You can't directly read the data out of it. You'd have to use like UTXO RPC or something like that. UTXO RPC again does not have a way to directly read transactions. I know we have a open pull request for it, but we don't have it yet. So there's no way to actually get a transaction. Only
I was testing. I was testing watch transaction, and it seems to work fine.
Okay.
Not the query one, but the watch stream.
Right. Yeah. So if you're watching for transactions, it'll definitely work that way.
Was that watching transactions using which platform? I apologize. Thank you.
UTXO RPC. Yeah.
We don't have a watch example.
Yeah, I was playing with one. I can share the link here.
Yeah, remember that I saw that watch here is watch.go. Is it this one also?
Yeah, there's a watch.
No, it's in my clone of Go SDK. I posted the link there.
Thank you.
And it has the ability to watch from a certain chain point, like block. So if I do that, I think I basically can get all the transactions from that point. Right.
So this is the
Correct.
watch.
Yeah. I mean, like that's what you can do with watch transaction. Correct. Is get all the transactions from a specific point.
And then from here, I can use the database package and then store it.
Yeah.
Exactly. That was exactly what I was getting at. Is how you get the data is separate from, like, that database package doesn't care how you get the data.
Yeah.
It's just the database part, and that's what it's supposed to be, is just the database part. So it's supposed to just be so that you can store and retrieve the data, and it already has shapes for UTXOs. And right, I don't explicitly have one for transaction, but we do have one for UTXO, and it does have indexes on both the transaction hash and ID, so you could just search, right, by transaction hash and get the transactions. So it's easy enough. We just didn't see the reason to create a separate table that has the same information in it. We just kept it in the UTXO table instead of making it so that we have to join across tables. So, but yes, that would absolutely work.
And also, where we will get the block hash and block index?
That's just from which point we want to start watching.
Okay. And we
we
are storing all the transactions, so it's like we don't filter anything here.
Yeah, specifically not that one, but in the later part, watch transaction with context, I was just manually adding stuff, so that's like not properly parameterized at all.
So like just the only transaction with this address inside it.
Yeah, if you scroll down a tiny bit, you'll see, you can add the a transaction pattern for address. Yep.
Does this means that if the address is providing input or output, doesn't matter, both of them will be recorded or picked up?
No, it will pick it up. Actually, yes, it will pick it up no matter where it is in this case.
Where it is. Okay. Well, that's kind of It's a little problematic because, well, it's kind of we are watching the users' wallets. Maybe they are interacting with something else. They're sending to someone else, and again, still we pick up that transaction because their address is inside it. So we need more filter. Am I right, Nelson? Like one address doesn't like we need to have, or maybe if it
Yeah,
is.
in those bullet point, this is the second one simply, and yeah, we haven't thought about the third one.
I see. By the way, in the index, are we watching the smart contract addresses or user addresses? Like we
I think it
are.
doesn't matter.
Differences to make.
Well, I mean, the difference would be if it is user, but we have to again be careful that the transaction that are related to the Andamio, sorry, will be recorded or will be watched, or at least. Uh, so there should be more kind of like the TX pattern should be more complex, having more stuff inside it. But if it is just a smart contract or dummy smart contract, well, now things are different. Just we can store all those transaction, whether it's input or output to that smart contract. Let's see. And by the way, this UTX RPC coming from where, Nelson? Is it locally or is it from Demeter or Blink Lab?
Yeah, I tried Demeter and I get watch transaction method not implemented. Tried Dingo, Dingo has implemented it, and yeah, it works. So yeah.
Okay, that's great. So we're on Dingo. We connected to this. And by the way, did you solve the issue of TLS? The one Chris mentioned that about the
Yeah, I'm
HTTP
using
issue.
the dial, so yeah, I'm not
Okay.
using that. Yeah, TLS.
Okay, that's great. So, do you think do we have enough utilities to start coding about this together, Nelson? Or still there might be something that we need to talk or cover about? Because I think uh, Chris just solved all the Yahtzees or question that we have. So that database package is basically everything probably Yahtzee was going to provide. Uh, Anything else do you think? Nelson?
Yeah, I think specifically with Go and nothing to do with Cardano. The third point. Uh, so yeah, we want to change or we want to increase the number of addresses being watched dynamically without reinitiating the server again and again, right? So maybe this is where channels are used, channels or what is it? Go routines. Yeah, I'm not a pro at those, so I'm not sure how we want to add more addresses. Any ideas on that?
Uh, but can we get these addresses from blockchain again? Like these are okay. Let me ask this question for clarification. What are these addresses?
I
User.
think that's a separate problem. Uh, let's not just worry about how we get the addresses, but the thing we want to achieve here is that when a certain condition is met, we want to add more number of addresses.
Number
So
of
I think it's a
addresses.
Golang.
Where exactly? I mean, in an example like here.
Yeah.
So maybe we can write a loop to see can we answer it with a loop. The length of the loop would be like you just go through that loop based on the number of the addresses.
Yeah, maybe it's easier than what we are
And then,
experiencing.
just merge all of those data which we got from all those addresses into one object. We append that. That function just return those, and and also this would be like we provide like here instead of just block hash. I mean, where is the place that we like? What does this return exactly? Nothing. I mean, it's just printing. Anyway, it would be like a slice, and it
Yeah,
won't
yeah.
be
I, I,
just.
I, I haven't properly thought about it, but yeah, I think it's fairly
Okay.
easy. The, when you see at line 102, the predicate is a list, so I think we can just
Yeah.
add objects there.
And we can append that to this object. So, okay. So do you, I think we have enough information to start coding about Andamia indexer.
Yeah.
We have the database. We can look into it to how to implement, how to integrate that into Andamia indexer. And also, well, are you already solved the issue of retrieving how to get the information? We have Dingo. We can run Dingo locally. We can watch the context. We can retrieve the information, and now we need to store this information into that database. But the third thing is the addresses whom we want to get the transaction are should not be constant. It is dynamic. So that's something we can think of an answer. Great. Just let me go to the chat. Scott says Cardano's public chain. There are no privacy issues. Well, and then are there identifiers for anonymity or just associated smart contract policy hashes? Yeah. Andamio. I mean, let's just not talk about just Andamio. I mean, you have a project. It's like anything. Normally, any project consists of a smart contract. I mean, normally, whether it is a NFT project, if it is a DEX, or anything, except if it is completely off-chain solution or something not blockchain that much related. And that smart contract has hash addresses, which that a script hash or a smart contract hash in some cases become NFT policy or the policy. In some cases become the addresses. So I mean, I won't go to the depth of that, but once you have that address, once you have the policy or script hash, you can just look into the blockchain, and that would be your identifier for yourself. And sure, if you have a solution, or I don't know, you have a project about some other addresses or other way, yeah, sure, you can do. But if you remember, here had in the Dingo database, in the plugin metadata, SQLite, and models. For example, UTXO, we have all sorts of things that we can look into. Like these exist inside blockchain. Some of them are, I mean, all of them are nested. Like everything exists in a block, and inside the block consists of transaction. Inside the transaction, and again, other stuff. So, but if you have ID, if you want to just monitor something or identify something, you can just like for payment key, sticks, all of that is just here. You can look into it, and based on your need, you can just retrieve that information. So address is not necessarily the only option for identify.
Yeah, if you go to the SQLite up and look down at UTXO there, you can see the actual functions that operate on the UTXO type.
Get
You've got
UTXO.
like a get, a set. Most of them I usually have like getters and setters, but there's like a few helpers like these after which are good for specific things. But like here's an example of how we're doing a UTXO by address, right? So the point is you could do the same thing to get it by anything else, right? And here's the TXN where down in here. Like this guy is where we're doing our actual SQL query. So this TXN where, right? That's where we're actually passing a GORM transaction, like line 106 there. Yeah. And so that's where we're actually generating our SQL query, right? So we're generating the SQL query, we're generating the staking key, and then you can see we add it together. So we have payment key, staking key, depending on which one it is. And then below we actually run the query, which is where the result is. Say so we're running where the deleted slot it's not deleted, right? And where the address matches. So we're determining what our address query is. Point is you can generate queries all that you want easily enough. You'll have the entire interface available. And that's the point is the plugin just gives all of the stuff and provides a bunch of things, but you don't have to use them. So if there's anything that's not there, right, like you can just write it. There's no reason not to. So, but anyway, yeah, we should have like UTXOs up by address already as an example because that's one that's used by UTXO RPC, right? And it's also used pretty heavily by the platform itself, right? Like when it's doing things, like validating stuff. So.
And it's also list. It returns a list of UTXOs. Yeah, I see. Yeah, thank you. And actually, this can be used inside a loop to get all these dynamic addresses.
Right. So, I mean, if you wanted a UTXO by transaction, for example, right, then you could look up all the UTXOs that matched a specific transaction ID by looking for, the where query would just be, where transaction ID equals, and then look for the bytes of the transaction ID. So, it should be easy enough to do most of the things. And you can see here that, we typically try to stick to using the Ouroboros ledger types everywhere because that's what we're going to end up with right on the wire or coming from the wire and that sort of stuff is we're converting everything to our ledger types, which makes it pretty easy for passing around.
Did we lose him?
I think we lost him.
Yep.
Mix.
He's gone.
Thanks for talking this through, Chris.
Yeah, no problem at all. And in fact, like this is perfect because it actually really reinforces what we're trying to do is we're trying to make it so that the pieces are reusable.
Yeah.
Right. So you should be able to pull up and use our database, right, to store the similar shape data, right? It's all the blockchain data, so we already have shapes for them. And if there are helper queries and things like that that make sense, right? Like if we find, hey, it really makes sense to have a get UTXOs by address or, like get transactions by or whatever to where like we generate transactions based off of what we look up.
Right.
That sort of stuff, is fine for us to add into Dingo, because the goal again is to make it pretty usable, right? So, and I mean, in other things Like, so you don't necessarily directly have to run Dingo. You should still be able to use it.
Sorry, everyone. I just
Welcome back.
experienced a power outage. Sorry for that. Oh,
Yes.
sometimes comment. I'm just joined with my phone.
Nice party.
Uh, so yeah, thank you, Chris, for all the guidance. Really, really, it was so cool. I wanted to actually show you about that Saber issue in Apollo as well. I just wanted to show that, am I doing something wrong? Because I talked with Eduardo and he wasn't able to recreate that. But once I used my code, it recreate this issue of the script hash is different. That the one generated in Apollo is different than the standards. But maybe again there are some cost model thing that he missed out. But yeah, that's the thing about Apollo. But
Is it
any
maybe once again the double encoding of Cardano CLI or Cardano API?
double encoding, like we should double encode?
Yeah, so Cardano CLI creates a script hash from a CBOR that's double encoded.
I don't know. I should check about that.
That's the
Do you-
one error we faced several times where you have to delete the first 5 or 6 characters of a Cardano CLI created CBOR.
I don't know about that. Actually, my system is shut down. I mean, otherwise I would look into that Sebo coding. But at the end, do you know, is there any place that talks about here? I mean, is there any CDDL, I don't know, standard ledger somewhere that talks about that you should double encode or you should do this or that?
It's just Cardano API that does it for whatever reason.
So others won't do it? Like, for example, Mesh doesn't do that?
I don't think so.
But if Mesh doesn't do that, they are able to submit the transaction. So like, maybe there is no problem. Maybe I don't know. Just
Yeah, mixed. It depends on where do you get the CBOR from.
well, I got the CBOR from Apollo. Send that to the Mesh. I mean the latest version, and deserialize that CBOR. Give that CBOR to. I mean, when popping up a signing message, users sign that message and then try to submit that via the front end. I'm not submitting that transaction via Apollo. And when I try to submit that, I get the same error. I mean, the error talks about integrity script hash.
Yeah, and
Which is,
I think that's in that integrity hash you have smart contract hashes in it. I think so. And do you get a different smart contract hash if you use Cardano CLI or if you use Apollo? At least
so if
I would
so if
I think
the thing that I didn't try it, find the time to do that honestly, was submitting the transaction via Apollo. So it's like getting that transaction again from front, sending that to backend, and submitting that. Maybe submitting that would be fine. If it is, probably that shows that Apollo, just Cardano CLI definitely do things differently, but maybe Apollo also does things differently. And the libraries which I use, Mesh and Lucid, these were two library, front-end library, are doing things differently or encoding or something. Yeah, that's something I'm going to test. If I remember, I tested that long ago. I'm not sure. I'm going to test that again about that. But Chris, have you tried this Portus version? Did you find the time to just, I don't know, testing something, for example, in Bluefin or implementing Portus version 3 stuff or support in any application you were working?
No.
Okay. So, and actually, my question is something that I'm going to look into. I didn't find it that much. That how Apollo understand that the UTXO I'm providing as a read-only contain the Pultus version 3 script receiver. That part is still it's not clear for me in that that merge or the push part all done. But the rest is it's okay. Just he added the cost model. There's some seaboard marshalling optimization also, but the rest is something I don't know. And also, I saw somewhere that he's using encoding option for seaboard. My again another guess is the canonical or non-canonical seaboard encoding probably again create different hashes, and that's the root of the problem. But I'm not sure. So yeah, I wanted to ask you guys, especially you, Chris, that if you guys try that push that Plutus version 3 support in Apollo, and if you face some issue.
We don't have a single use case we would have to test Plutus v3. We don't deploy smart contracts. So I don't have any way to test it. That's why I was kind of deferring.
Doesn't Bluefin use a smart contract? I mean, as a read-only UTXO, like seaboard?
Yeah, it's v2.
It's the V2. Do the team wants to upgrade to V3 or something, or no? It's just they want to stay in V2.
I don't know that they're rewriting any part of it.
Although I should say that I was experiencing same issue with V2 as well, like a year ago around same time, and to be honest, we didn't figure it out what was the issue. Eduardo had this kind of suggestion that maybe the order of the UTXOs inputs are doing something in regards to that C4. He pushed something in another branch of the Apollo. If you had time, please look into those branches that those UTXO input UTXO are being sorted, not based on their. I guess it's not based on their hashes or something. It is sorted based on something else. And also something we noticed, I don't know if he fixed that or not. The inputs, the UTXO inputs, and the UTXO that a smart contract wants to interact with those. Like for example, there are two UTXO coming from two different smart contracts in one transaction. That's became problematic if the order changed. That was something I don't know. He fixed it as well. That's it. I'm sorry I lost the power, but does anyone have any question or anything they want to discuss? Not, maybe we can
No,
close.
I think we're good. I mean, I think maybe we can just call it a little early. And
Okay. Yeah, thank you. And hopefully we will talk about more of the upload maybe tomorrow. You know, when I find something. And yeah, that's all. And again, thank you guys. Thank you, Chris, really, for your guidance and helpful tips. And also, whoever is going to watch this video, please, if you have any questions, there is a dedicated channel in Gimbalabs Discord server. You can go and ask your question or share your question. We didn't, I mean, I had the plan to look into it, to answer some of them, if there are any, but unfortunately, I'm not able to do that now. But yeah, thank you for everyone for joining. Hopefully we will continue next session about our progress or some on the indexer. We want to use this project I mean, the whole idea of this session was using the available tools. So just Chris pointed out code base to, you know, building real world projects or products. And this is an example. There are other examples that we want to, I mean, there are many other things that Blink Labs and other projects provided in Golang ecosystem. I hope to use them all, or at least showcase them in this video. If you find them useful, yeah, go for it, use them. So have a great day and night. See you soon, and take care.
Thank you, Professor.
Goodbye, everyone.
Yeah, thanks everybody.
Thank you, James. Thank you, everyone. Goodbye.